In this example, we have the integral of cos to the power of 4x dx. That is the integral of cos squared x squared dx. So what we're going to do again is use the double angle formula for cosine. This time though, the form that we're going to use, because we have cos squared x, is cos 2x equals 2 cos squared x minus 1. We can rearrange that to make cos squared x this subject and get cos squared x equals 1/2 times 1 plus cos 2x. In this question though, what we have now is the integral of 1/2 times 1 plus cos 2x all squared dx. This means we need to square our bracket. So there's a little bit of working over to the side. We have 1/2 times 1 plus cos 2x all squared. That is the same as saying 1/2 squared times 1 plus cos 2x all squared. 1/2 squared is a quarter. So we've got a quarter times 1 plus cos 2x all squared. So 1 plus cos 2x times 1 plus 2 cos 2x, a perfect square, is going to give us 1 plus 2 times 1 times cos 2x, so 2 cos 2x, plus cos squared 2x. This now has introduced us with a little bit of a problem, because we still now have a cos squared term that we need to anti-differentiate. But similarly as before, what we can do is think of our double angle formula. If we were to consider this variation of your double angle formula, cos 2ax equals 2 cos squared ax minus 1, that is, a is equal to 2. If we rearrange that to make cos squared x the subject, we would get cos squared ax equals 1/2 times 1 plus cos 2ax. As we said, a is equal to 2, so substituting into that formula, what we now have is 1/4, 1 plus 2 cos 2x, plus 1/2 times 1 plus cos a being 2, 2 times 2 is 4x, all squared. So, expanding that and then gathering your like terms, we would get 3/8 plus 1/2 cos 2x plus 1/8 cos 4x. This we can now substitute into our integral. We have the integral of 3/8 plus 1/2 cos 2x plus 1/8 cos 4x dx. So now we can antidifferentiate each term. The antiderivative of 3/8 is 3/8x plus the antiderivative of 1/2 cos 2x is 1/4 sine 2x plus the antiderivative of 1/8 cos 4x is 1/32 sine 4x plus c. Please note, I wrote a squared there. That squared should not be written. The rest is correct.